In this video, we will write down the structural formula and carbon skeleton formula for all possible chain isomers of C6H14. Let us determine the degree of unsaturation value for C6H14 to see whether it is a saturated elemental composition or not. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2. Therefore, this is equal to 1 plus, we have 6 carbon atoms here and 14 hydrogen atoms. So 14 by 2. Therefore, 7 minus 7 equal to 0. So this means that this is a completely saturated elemental composition. Only alkanes are possible. This will fit into the general molecular formula CnH2n plus 2 with the n value equal to 6. Let us write down the structures one by one. We can definitely write hexane or N-hexane. The structural formula is CH3, CH2, 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 CH3. And the corresponding structure in bond line notation would look like this: 1, 2, 3, 4, 5, 6. Let us just number it. This is called N-hexane or simply hexane. And then number 2, we can also write 2-methyl pentane. And the structural formula for 2-methyl pentane is CH3, CH, CH3, CH2, CH2, CH3. And the corresponding structure in bond line notation will look like this: 1, 2, 3, 4, 5, and then at 2 position 1 methyl group. This is 2-methyl pentane. Let us go to structure 3. We can also write 3-methyl pentane, and the structural formula for 3-methyl pentane will be CH3, CH2, CH, CH3, CH2, CH3. The corresponding structure in bond line notation will be 1, 2, 3, 4, 5, and in the third position 1 methyl group. 1, 2, this is 3-methyl pentane. And then number 4, we can also write 2, 2 dimethyl butane. We are exhausted with the pentane chain because if you put the methyl group at 4 position and then if you number it right to left, that will become 2-methyl pentane again. Therefore, that is a repetition which we should avoid. So we are moving to the butane chain now. We can write 2, 2 dimethyl butane. So at 2 position 2 methyl groups. And this gives a quaternary carbon. This is a 4-degree carbon or quaternary carbon. And the corresponding structure in bond line notation will look like this: 1, 2, 3, 4, and then 2 methyl groups at 2 position. Let's number it: 1, 2, 3, 4. This is 2, 2 dimethyl butane. And then one more structure that we can write is number 5, 2, 3 dimethyl butane. Instead of putting both the methyl groups at 2 position, we are going to put methyl group at 2 different positions. One is at 2 and another is at 3. So CH3, CH, CH3, and then again CH3, CH3. And the corresponding structure in bond line notation will be 1, 2, 3, 4. At 2 position 1 methyl group, 3 position 1 methyl group. Let's number it: 1, 2, 3, 4. This is 2, 3 dimethyl butane. We cannot write any other isomer for this elemental composition. In this question, they have specifically asked to identify all possible chain isomers of C6H14. Can we just say that comparison of any two isomers is a chain isomers? No, we cannot say that. For any given two isomers, if the parent chain and or side chain are different, then they are chain isomers. On the contrary, for any given two isomers, if the parent chain and side chain are same, then they are position isomers. And therefore, we need to distinguish between chain isomerism and position isomerism in this problem so that we can find out all the possible combinations of chain isomers. Let us do this one by one. So here I have gathered all the 5 different isomers of C6H14, and therefore let us identify based on the definitions that we discussed before. So if the parent chain is different, then they are definitely chain isomers. We have hexane in number 1 and that is not repeated elsewhere. Therefore, any comparison of one with the others means that we are talking about chain isomerism. Therefore, 1 and 2, 1 and 3, 1 and 4 and 1 and 5 are indeed chain isomers. How about 2 and 3? Are they chain isomers? No. Here the parent chain is same, pentane. Side chain is also same, methyl group. Only the position of the side chain differs. Therefore, 2 and 3 are position isomers. They are not chain isomers. How about 2 and 4? Parent chain is different. Side chain, in one case it is methyl, in another case we have 2 methyl groups. So even though the side chain can be considered as same, but we have 2 methyl groups in one case, 1 methyl group in the other case, and also the parent chains are different. Therefore, they are definitely chain isomers. 2 and 4 are chain isomers. 2 and 5 chain isomers. Parent chain itself is different. How about 3 and 4? 3 and 4 definitely chain isomers because parent chain itself is different. How about 3 and 5? Parent chain is different. Therefore, 3 and 5 are indeed chain isomers. How about 4 and 5? 4 and 5 they are position isomers because parent chain is same. Side chain is also same. In both the cases methyl groups. However, in 2,2 dimethyl butane, both the methyl groups are at 2 position. In 2,3 dimethyl butane, one methyl group is at position 2 and the other methyl group is at position 3. Therefore, 4 and 5 are position isomers.